We are looking at our last lesson. It is on what's called simulations. And so think of the word simulation. Those of you who like to play video games, you might be able to tell me what a simulation is. A simulation is whenever you can't do the real thing, and so you're going to simulate it by doing something else. And so a simulation is used in probability whenever it just doesn't make sense or it's not feasible to actually do the experiment. Instead, we're going to simulate it by modeling the action in this given situation. And so that's what a simulation is. We're modeling it. So we are still being able to find the probability and using the correct probabilities, but we're just not actually doing the real experiment. And so a few other things about simulations, like I mentioned, it's done and often used to act out an event that would just be impractical. It just doesn't make sense to do it in person. Maybe we don't have the resources to do it. Maybe there's too much involved to actually doing it in real life in person. And so we would use a simulation. Examples of simulations are things that we've already talked about before. Spinning a spinner, using what's called a random number generator, where you tell the computer what numbers you want, like 1 through 5, 0 through 9, and then it just randomly generates a number. Rolling dice, tossing a coin, pulling marbles out of a bag. There might be more than one way to simulate an event, but we're trying to come up with the best way to simulate. And you can, as long as you can explain correctly how you would simulate this event, there will be more than one answer to many of these questions. Some of them, only one or two would work, but there might be more than one answer to some of these. And so the key is to figure out which one would work based on how many choices there are, how many options there are, what the probabilities are, how can we best kind of split up everything, and then which one is, and then can we explain which one we have used. So that's our goal for today. So let's look at our first example here. It says a restaurant is giving away one of 5 different toys with its children's meals. If the toys were given out randomly, describe a model that would be used to simulate which toys could be given with 6 children's meals. So I want you to first ask yourself, how many different options are there? And are they all random? So random, remember, it says that they're given out randomly. Remember, random means that everything has the same probability. And so what's something we could use? There are 5 different toys that we could give out. What's something we could use that we could have 5 different options and all of them have the same probability? Well, we can't flip a coin because a coin only has 2 options. We can't roll dice because dice only have 6 options, not 5. So maybe one way that we could do this is to use a spinner. So I'm going to say we would use a spinner. We also need to say how many times we split up that spinner. So we would split this. There are 5 different options. So we would split into 5 equal parts. This is the important thing. You need to tell me not just 5 parts, because if you split it into 5 parts, it could be, I can make it look like this. If it wasn't equal, I could do this. That's not random, okay? That's not equal. So this would not work. So you need to tell me that it's split into 5 equal parts. And then how many times are we going to do this? Well, read what the question says. We're trying to see how many would be given with 6 children's meals. And so we would spin 6 times. So each part represents a different toy. And we would split that spinner into 5 equal parts. Now, there's 2 other ways we could do this. If you would rather use a random number generator, you would need to use 1 through 5, 1, 2, 3, 4, 5. Assign each number to a different toy, and then do the random number generator 6 times. The other one we could use is pulling marbles out of a bag. You would need to have 1 marble of 5 different colors. So maybe a red, blue, yellow, green, and orange. And then each color represents a different toy. You pull one out, and then you put it back in, and then do it again 6 times. Make sure you put it back in because you always need to have 5 marbles in the bag whenever you pull out. So there are 3 different ways you could explain this. A spinner, 5 equal parts. random number generator, 1 through 5, or marbles in a bag, each marble is a different color. But we use a spinner for that, and that's how we would explain. You need to make sure you are specific as possible, so that way there are no questions as to how you would do this simulation. Okay, so the next one, I want you to read that, pause the video, and think about what could I use to represent this situation. Okay, so once again, the word is random. So whenever you do this, all of the possibilities need to have the same probability, the same chance of happening. He picks one of his 6 ties. So this one, what makes the most sense? If we're talking about 6 different ties, the best thing that we would do would be to roll a die. And we just need to do one of them because one dice has 6 different options. They all have the same probability. They're all random. And so the next thing you would also need to say is assign each tie a number. Which is 1 through 6. Okay, and then once you've done that, you'll roll each day. So if he lands on 3, on Monday, he would wear the tie that he's given number 3 to. He lands on 4. On the next day, he would choose tie number 4. 6 the next day, choose tie number 6. And so that's what you would do to roll a die. So make sure that you say each tie gets a different number, 1, 2, 3, 4, 5, or 6. And we would roll a dice each day. You could do a spinner, 6 equal sections. You could do a random number generator. But if there are exactly 6 and it's random, choose a dice because that is giving you 6 different options. So those first 2 deal with if the probabilities are random, if the same probabilities or if they're the same for everything. You could also have simulations where you need to simulate or model the situation, and they are not random. One chance is greater than another. So in this case, there's a 60% chance of rain for each of the next 2 days. Describe a method you could use to find the probability of having rain on both days. So now we cannot, there are 2 options, right? There is rain or no rain. You can't flip a coin because this is a 60%, 40% chance. Flipping a coin is 50-50. You can't roll a dice because dice are all the same probabilities. And so think about, how could I do this? Well, I'm going to say let's use a spinner. Now there are 2 different options. So we're going to have 2 different colors. But if I have a spinner, okay, and you tell me to split one section as 60%, one as 40%, I don't know if this is 40%. It looks kind of like 40%, but it's not exact. And so you cannot say split it into 60% and a 40% section. So think about a way that you could do this so that you would get exactly 60% and exactly 40%. What I would do is think about the percent. 60% is 60 out of 100. And simplify that. That simplifies to 6 out of 10. So let's see if we can kind of put the pieces together. You need to divide this spinner into 10 equal sections. And out of those 10 equal sections, how many of those sections would represent rain? Well, 6, right? 6 out of 10 is 60%. So 6 represent rain, 4 represent no rain. And you would probably want to label those, or maybe blue is rain, red is no rain. And then you need to spin this twice because you're looking at it for 2 days in a row. Okay, so anytime you have to deal with something where the probabilities are not the same, you either need to use a spinner, a random number generator, or marbles in a bag. If you did a random number generator, you would want to use numbers 1 through 10. 1, 2, 3, 4, 5, and 6 represent rain. If it lands on 7, 8, 9, or 10, it represents no rain. And then if you want to use marbles in a bag, you just have two options. So you just need two colors, either rain or no rain. So blue represents rain, red represents no rain. There would be 6 blue marbles and 4 red marbles, 10 total, but 60% for rain, 40% for no rain. So think about that and how you would have to split these up if the probabilities are not the same. And I want you to answer this last question. Okay, so there's an 80% chance that he makes his free throws, which means there's a 20% chance that he does not. So once again, you could either use a spinner, you could use a random number generator, or you could use marbles in a bag. So for all of these, you would want to have 10 total options. So you just want to pay attention for this. I'm not going to write everything up on the board. 10 total sections for the spinner, 10 numbers for the random number generator, or 10 marbles for marbles in a bag. You would want to have 2 different colors or 2 different sections, make or miss. So let's say for the spinner, how many of those sections would represent make? Well, 8 would represent make, and then 2 would represent miss. 80% versus 20%. So 8 sections represent a make, 2 sections represent a miss. 8 numbers represent a make, 2 numbers represent a miss. 8 marbles are the same color, they represent a make. 2 marbles represent a miss. And they're the same color as well. The only other thing is if you choose marbles in a bag, you need to make sure that you say to replace the marble or put the marble back in before you draw it again. Because you're doing this twice. So draw a marble, put it back in, and then draw it again. Draw another marble again. Okay. So that's using simulation, simulating different events, modeling them using probabilities, and we can do that if the probabilities are the same, if it's random, or if they're not the same, if it's not random. Okay, so if you have any questions, be sure to let me know, but they're the questions that we're going to be working on for simulations.